have you tried to build a dipole? We're going to build one today, and it's one of the easiest antennas to try. We're going to do it with the 80-meter WSJT frequency of 3573, and we'll get the SWR down to 1:1, or just slightly above. But I'll show you how easy it is, and it's just a matter of getting the exact dimensions. Okay, let's look at our frequency. So we're after 3573 kilohertz, or 3.573 megahertz, and that's the 80-meter WSJT-X frequency. So I want to cut an antenna for exactly that frequency. We do 300 divided by the frequency, 3.573. Let's do that. That gives us 8396. Now that is one wavelength. So what we do is we divide that by 4 to get a quarter wave, and that's 20.99907. So a quarter wave, 20 meters, 991, and that's meters as in the length of the actual the quarter wave. So what we do need to do now is to work out the exact length to cut it to, and because we're using not straight copper wire, we're using insulated wire. My wire I'm using is V90, and I'm quite happy with the velocity factor of 0.93. So if we go 20.991 times 0.93, that gives us 19.521. So if we get the velocity factor, 19.521. Okay, so that's in meters. Now that is each length of the dipole. No, so we have 19.521 this side and 19.521 this side. Okay, so I went ahead and made 20 meters and 20 meters. And in the center we've got our B and C connector, which has the 2 terminal posts on each side. Then I made a loop at the 19.521, so I left a little bit of extra and put it on the V&A meter, and it came out to 3430 as our center frequency. So if we do that calculation again, 300 divided by 3.430, that gives us 87.46. That's one wavelength. Divided by 4 gives us 21.86, and we multiply that 0.93, gives us 2033. So that's 2033 meters. So now if we take off our target, which is 19.52, that's 19.52, gives us 81 centimeters. So we need to cut 81 centimeters. So to shorten my 20-meter cuts down 81 centimeters, and we should be right on that wavelength. So as you can see, what I first did was 20 meters actually equals 3.43 megahertz. Okay, take the 81 centimeters off, and then that brings us down to our 3573 megahertz. Now, what I did is I did one cut on one side first, and that brought our SWA down. And then I came across and cut the other side to give us that 19.521.
So as you can see, it was very cheap to build. It was just a BNC connector with the terminal posts, a very cheap connector from a local electronics store, and then just two pieces of wire. I was using V90 wire, which is quite durable, and I found to be quite good on most frequencies. And string it out, and away you go. One of the easiest antennas to make. Thanks very much for watching, and if you like this video, subscribe.